set of numbers you guys figure out too. Okay.
Some of that.
So, before we move on, were there any questions on the graph ones? They should be fairly straightforward, right? They're all velocity time graphs. If you want to find an acceleration, you're just looking for a slope. If you want to find displacement, you're just looking for area. And then keep in mind, just quick clarification. There's been some confusion in the past I always say area under the curve because it's shorter and easier to say, but technically you should say area bounded between the curve and the time axis, but obviously that's a mouthful. So like for on 14, for example, what's happening over here? Like this is negative displacement, right? So where's the area you're finding? It's this. So is everyone okay with that? So this describes a particle that was at rest. He sped up, hit a max speed of 4, then started slowing down, right? And then he stopped momentarily, started going left. Now, what does this represent? What was he doing here? He's at a constant leftward speed, right? He's going 2 meters per second to the left. Then he slows down, comes to rest momentarily again, speeds up, hit a constant speed of 1 meter per second for the last couple seconds. Everyone okay with that? Okay. So, like for example, in that first part of in his initial forward movement, how far did he travel here? Base times height divided by 2 is 8. So he traveled 8 meters forward, then he traveled backward 6 meters, right? That's 6. And then he traveled, let's think, is that 6? No. It's, hold on, that's 2, 3, 4, 5, 6. It's 7, isn't it? Right? That's 1 plus 4, and then this is 2, right? Some crazy. Yeah? Okay. So sorry, 1, 2, 1 plus 4 plus 2. So that's -7. So we travel forward 8, then he traveled backward 7, and then in here it's 1, 2.5. So forward 2.5 meters. So all right, okay with that? All righty, let's move on. It is advisement schedule today. It's on that pink sheet if you really want to know. What?
Yes.
Okay, so looking forward, we're going to do a bunch of word problems. This is more typical of the kind of question you see on like kind of classic physics questions. The graph ones, you're definitely probably going to see something like that, but these are more common. So if you take, say, college physics class, this is you're very likely to see questions like this a lot. So a car starts at rest and starts experiencing an acceleration of 4 meters per second squared for a period of 8 seconds. By the way, just for the video, it's number 15, right? Okay, number 15. So try this out yourself. Write an equation for the car's velocity as a function of time. Find the car's final velocity. See if you can figure out the car's total distance traveled. My hint to you for that is if you get stuck, try sketching a rough sketch of the graph, and then you'll be able to figure it out. And then find the car's average velocity. So 3-step problem. So go take a minute and try it out. See how far you can get. if you're stuck in the first part, here's a hint. Word is kind of weird. I just realized that. It's kind of like a typo there. Hopefully you know what I meant. Fix the typo. Did everyone get the function? So, Emily, what's the function? Give us the answer
The answer?
to part A.
Okay, I got 32 meters per second.
Good, that's the car's final velocity. And then what was the equation for the car's velocity as a function of time?
I'm still reviewing that.
Okay. Good, I agree with your final answer. So guys, who has the function? Anyone? Winslow thinks he has it?
Be like velocity.
Mhm.
Plus where we started, so this is zero. So it would be
You got it. You got it.
4 times 8 plus 0 equals 32.
Yeah, so the function is, we're starting off at 0, and every second we're gaining, was it 4? There you go. So your velocity, now let's think about this. What does this say?